we can use the domains to associate with solids and combine the two information. So to demonstrate that, we are gonna do it in here. Because we only have the two shells for solids, we do not have a solid for the background, and we need to associate one domain per solid. We need to create a subset of our domains. So in order to create a subset of the shells, you're gonna do shells equals to domains get subset, and then we are gonna just get the low grade and the high grade, and we're gonna name it shells so we can take a look at what shells is. So we loaded the domains, and within the domains we are saying, well, we want to create a new categorical variable that's called shells, and this categorical variable you only contain the low grade and high grade subset. So we are kind of dropping the background, and that's what the resulting values are. So now that we have our subset, which is called shells, what we can do is to associate those domains with the solids. So within RMSP, so far we have looked into solid, which is a individual solid, but we can specify a collection of solids with the object solids. So what this one takes are the solids, a list of solids. So let's say low shell and high shell, and then we can associate that with a domains object, which is shells. So note that the ordering here should be the same order of the shell of the solids that I provide, and I can just save that into this solids object. So the advantage of collecting all the solids into a single object is that it will streamline operations. So for instance, what we can do is to go solid.view 3D, and then let's just generate the view. So this will add both solids to the 3D viewer. In this case, we can decide to change some properties. So for instance, I want to change the alpha just for the low grade. So I can do alpha equals low grade and then the value for the alpha. So it generates a 3D viewer with the alpha value changed just for the low grade. So I no longer need to loop over all the solids in order to add them to the viewer. It will do it for me. It will label it properly. It will color it properly. So it's less work. So the next one, for instance, is we can create a subgrid. So in the previous notebook, we saw how to create notebooks with the dictionaries that we specified. Here, I just want to demonstrate that we can create subgrids using this solids object as well. So let's do subgrid data from solid. This is the same function I demonstrated in the previous notebook. So we are gonna specify solids, and because my solids only contains the low and the high grade shell, I want to create a new variable based on the topography, so we can slice that as well. So we are gonna specify this as a list. So the first variable is gonna be controlled by the solids, and the second variable is gonna be my topography. Because I do not have a particular object that holds the topography, we can just specify as a dictionary. So everything that I flag with topography, which is gonna be flagged with code 1. So now, because we have two sets of wireframes, we need to specify two variables. So this one is gonna be shells.call, And next one's gonna be topo, just topo column. And now we can specify how to flag. So for the first set of solids, we are gonna flag inside the first, which is the low grade, and inside the second, which is the high grade. And for the topo, which is the second set, we are gonna do below, and we are gonna use the topo as a boundary as well. The next one is the minimum block size. It's gonna be 5 by 5 by 5, and the parent block sizes is gonna be 15 by 15 by 15. What happens when I flag this? What happens when I flag this is that the shells has a lot of this missing number, and this missing number just means that it hasn't been flagged by the low grade or the high grade. So it's just missing, so we can replace that by the background. So actually I'm gonna use the original domains column for this because I'm gonna assign the background separately. So let's just take every location where this is called equals to RMSP.missing int. So this is the first time we're looking to this missing integer. So RMSP.missing int is the missing value for the integer data type. So for instance, we can have missing float, which is just NaN, the same as numpy NaN. So this is gonna provide us the missing integer. This returns a mask, which we can use to slice the grid, and then we can assign the domain column to use the background code, which is gonna come from domains background dot code. So when I run this cell, now my subgrid has a domains column and a topo column, which were created by using the solids and the topography. And what I can do now is visualize. So let's create a view similar to the view we were looking before. So that's gonna be coordinate equals 850, and let's start adding elements to my figure. Actually, we can go back to the previous notebook and just copy the code from there into here and just check if we have everything. We do. The only thing I want to change here is I do not need this loop anymore. I can just do solids dot section plot draw axis view tolerances 0 and trace. Okay, so this should be all. And also this is now domains column. So that's how we created a subgrid using our RMSP.domains and RMSP.solids.